So I see we've started the meeting. This is our webinar, which we do regularly. This one's gonna be a little bit different. We are excited to launch a brand new product that is a little different than what you may expect from a console product. This one is like something we haven't done before. Very hands-on, very much aimed at student participation. In fact, it's completely based on student participation. And here to go over our EV-100 is Jérôme from our education team. Before that, though, I want to thank Jérôme, who is an active member of the military, and also any of the other veterans who are in here. Yesterday was Veterans Day, but just remember, every day should be Veterans Day, so thank them as often as you can. And we want to thank Jérôme for his active service and service to his country. And now, Jérôme, you can take it away and tell us all about this EV-100.
Yeah, thank you, Jimmy. So yeah, you're right, Jimmy. This is a completely new type of product that we decide to basically come up with. Is we like to call it like a project where the student's going to be really engaged. It's all about building their own electric brushless DC motors from scratch. Everything come out inside that little box here. So basically they have like all the instructions. It's like an IKEA type of product where or building some Legos basically. So they're just gonna go through all the step-by-step and basically building their own, like I said, electric brushless DC motor. So they start with a empty base, which basically contain a controller. So the thing is, depending if you're teaching like a STEM program, trades, even engineering, that type of product, we believe it's the right tool for hands-on learning and basically just like discover new type of technology that we more often see in today's vehicle. So I like to say like new type of technology, but if we think about it, there's so many vehicles that are now driving on down the road that use like brushless DC motors, such as like fuel pump and whatever we're thinking about, like the blower motors, even some engine that are using three-phase brushless DC motors for the cam phaser, for example. So many application, robotics, CNC machines, whatever, are using this type of motors. So this is why we thought that sort of a product is basically good for instructors to just add to their classes. And basically, we do believe that building it, knowing every step that is really important in that construction of those type of motors is the way for the students, for example, to basically just knowing exactly what is going on, what's the science behind that motor. And like I said, during that building, so many things can go wrong. For example, bad connection or wrong polarity, whatever. So each little mistake or happy mistake where students gonna learn why that motor is not starting or not turning and how to diagnose it. So you can basically take that product and teach the fundamentals, the most basic things around those type of brushless DC motors. Or you can go and more advanced classes and use, for example, I don't know, like a picoscope with 4 channels. So you can go ahead and scope each phase and have a pretty clear graphic on your computers, which all the phases together. You can compare the pattern that you're going to see on each phase and see if the amplitude is the same on each one of those. And if there's a bad connection, what's going to happen to the pattern and so on. They can teach to use tools that new technician on the automotive industry going to have to use. Lots of isolation testers, so megometer, for example, so you can basically do some isolation testing on each individual bobbins. You're going to also learn to use like a milliometer to basically check the integrity of each individual bobbins. And again, those tools going to be more commonly used on different EVs or hybrid. So many manufacturers, such as Toyota's, basically ask the technicians to check the integrity of the stator of, let's say, their Toyota Prius, for example. So yes, we are starting from the base where you're going to basically have some bobbins that you're going to round up and make some like 50 turns on it. On those, you're going to have to clear the isolation on the wire itself, just to make sure that basically you're going to have some good connection on each phase. You're going to then assemble each individual phase. And you know what? I'm just going to go ahead and show you on the other camera, so you're going to have a pretty clear view of what I'm talking about. So I'm going to switch this camera here. Let me break a couple of stuff here. There we go. So, like I said, so students going to start up with an empty base where they're going to have some WAGO connector for each phase. So we're going to have our UVW phase. And with that instruction manual, where they're going to have to follow step by step, every step from the beginning till you're going to have like a fully functional electric motor, where the student's going to just plug in the motor, spin that little control knob here, and make it turn if everything was properly done. Just the impact for students to be able to build with their own hand the electric motor itself is something that they're going to remember. But like I said, there's so many things that they're going to learn during the construction. So we're going to have two types of bobbins that they need to manually wound those bobbins, clockwise and counterclockwise. Then they're going to learn about the polarity. What's going to be the impact from having a bobbin clockwise and a bobbin counterclockwise? Then they're going to have to put the magnets, so the neomagnets, into the rotor itself here by inserting the magnet to the right position. What I mean by that? So, of course, to be able to have a fully functional brushless DC motor, you're going to have to put the magnet in a certain order, such as south, north, or north, south. So you can use a polarity tester that came in a kit of 12. So like I said, here we're going to have a south pole magnet. If I spin the rotor, we're going to have a north pole magnet, south, and north. So imagine the students who didn't follow the step by step and put the magnet in the wrong orders. Let's say, I don't know, south, south, north, north, or whatever, that type of combination, that motor won't start or will be like super inefficient. So then you can go ahead and do some tests, and they can understand what's going to be their mistake, and again, fully understand what's the impact of having a bad rotor. Speaking of kit of 12, so that product, of course, can be buy individually in kit of 12 or even in kit of 24. And basically came in a big case, whatever you're buying in kit of 12 with extra parts and a polarity tester. We do have 5 magnets that come with that product, so you can only use 4 magnets for the rotor. And the 5th magnet is going to be to show the students how to use an extra magnet to confirm the polarity of those magnets, so you can put the magnet in the right order into the rotor. So if I'm taking the fully assembled rotor here, we can see that the top of the rotor, the cap itself, it's clear. So basically, it's allowed the students to really see what's going on inside the electric motor, whatever it's fully assembled, and they plug it in and make it run. So they can see that the rotor at first, because it didn't have a resolver for the controller to see where's the exact position of the electric motor, they're going to try to basically make it run, make it spin. And then if everything is in the right order and like wired properly, the rotor going to start to rotate. And then one of the basically one of the advantage of having this type of motors be able to precisely control those motors. So you can really, with that knob on the controller, make it spin fast, or you can control to make it turn super slow. So they're going to be able to see everything, all this phenomenon with that clear top here. So, like I said, they're going to wind the bobbins. They're going to assemble each individual phase. So each phase is going to be different. So UVW going to have like clockwise, counterclockwise series of bobbins depending on which phase you're building. And then you're going to just simply wire up the each phase to the waggle connector on the side of the base and assemble the stator itself. So now the student's going to have to build their own rotor and their own stator. So basically they build everything about that electric motor beside the controller itself. That being said, even if the controller is already inside the base itself, doesn't mean that the instructor doesn't have to talk about the controller and how we manage to have like DC in and basically with the controller inverted to AC with, for example, all the MOSFET, IGBTs, and so on. So so many discussion point that the instructor can teach about. So that is the final look of a fully assembled unit. So like I said, you're gonna have all the bobbins basically wind up and place around the rotor itself to form, like I said, the stator. And again, we suggest to have each bobbin with 50 turn of those wires, but you can teach about what happened if I have like 25 turns of wires. What's going to be the effect on the magnetic field? What's going to be the effect of the heat generated and the amperage? So less wires, less resistance, less turn, less resistance, more amperage, more heat. What about the magnetic field? If I have a bobbin with 50 turn and another one with 100 turn, make it like super big. What's going to be the effect on the magnetic field? And a cool thing about that unit is you can also test each bobbins with that base without using any tools. If you want to show something really cool, is to plug a bobbins on the phase here on the waggle connector for each phase. So let's say I have a bobbin that I want to test. I'm going to put it on the U and the V, and depending on the number of turns on that bobbins, the magnetic field is going to be stronger or less stronger. I can use like a normal steel nut and see what's going to be the effect on with the bobbin itself. So that is something really cool to be able to show the students. When we talk about brushless DC motors, we refer to electric motor. Yeah, that's a good thing, but we can also use a pulley here with a rubber band, and we just created our own generator. So I can manually turn the rotor, and again, I can use a DMM, wire it up to each different phase, generate a voltage, can scope it out, can see the pattern, and this is a good way to do some diagnosing on the motor itself. So imagine I have a students who have built the motor, and basically it doesn't spin. one of the steps that you can go ahead and do with your students is put the pulley on the base, put the rubber band, use a U-scope, for example. A simple U-scope can work perfectly fine. So we do not have to use the picoscope, which is great, which you're gonna have all three phases, but costs a little bit of money. You can use a standard U-scope, such as this one that I got here, super simple to use. Basically, I'm just gonna hook up to each individual phase. This is one channel U-scope, so I'm gonna have to switch in between phases. But basically, I'm gonna have the students or myself turn manually that electric motor, generating some pattern on each different phase. And I can see and point out which phase is the problem. So imagine I have a bad connection on the phase U. Then I'm going to have a pattern on the V and the W ones, but not on the U one. So I know that there's going to be a problem with that phase. Now what I can do is basically use some simple tools such as a DMM and let's say insulation meter or even a million meter like this one. And I really love this tool basically for some diagnosing. So imagine I have a motor that is not spinning like smoothly. And what I need to do is basically test each individual bobbins of one of the phases that I found out to be bad. Let's say, oh yeah, I test my my three phase and I saw that the pattern on the phase U is not great. Phase V and W are good. So I'm going to use that million meter. First thing first, what I'm going to do is basically zero it. So I'm going to make sure to have good readings. There we go. There we go. There we go. Okay, so I'm going to test one bobbin and then I know that I have 50 turns. So hook up both wires and I have about 86 milliohms, right? So that tool is super precise. It can really see the integrity of every wires. So I have these bobbins with only 25 turn. So if I do the same thing and test both sides of the bobbin, as we can see, we have now about 39 milliohms. So, like I said, Toyota basically has their technicians to do more and more testing on the stators to verify the integrity of that component with medium testing. So this is really relevant to diagnosing such a motor. So this is a really good opportunity for an instructor to teach about it and like I said, for the students to really fully understand the usage of different tools and why are we using that particular type of tools for diagnosing. Like I said, I'm just going to do a little demonstration with the U-scope. So I'm going to take a U-scope. I'm going to basically hook up that U-scope on one phase. So there we go. I'm going to change my settings. There we go. There we go. So everything is hooked up and I can manually spin make sure that I have good connection here. There we go. Here. make sure that I have good connection, and I can go really slow. So I'm going to have a pattern with an amplitude super, super low, or I can go really fast, and the amplitude and the frequency, of course, is going to change. And I can test each individual phase of it. I don't know if you can really see it on the camera, or I can, okay, let me do it again. So I can really see the pattern changing, and I can even, you know what, try to make it a bit bigger. Here we go. So I can really see the pattern changing. I can go both ways. So counterclockwise or clockwise, doesn't really matter. But the thing is just a good opportunity to try to introduce new tools, or even tools that students already know, but now they're going to use it just to make sure that everything's fine, and or doing some diagnosing. So let's say the students have already built everything. Now's the time for them to create a little magic, have that power supply plugged in. And like I said, we can clearly see inside the rotor itself, so we can see the magnets. So with that little knob on the controller, I'm just gonna slowly increase the power. As we can see, the magnets are now trying to turn. And this is why I told you guys earlier that that product didn't have a resolver. So basically it's just trying and trying and trying again to start the motor itself. I can give a little spin. We're gonna have like a little bit more and more turns, but I can basically go ahead and increase the power until the motor run and spin. And then again with that same knob, decrease the power, increase the power. It can and basically teach the students that those type of motors are really, really, really precise. Everything's made with that controller inside. So with those type of technology, it's more common to see those type of DC brushless motor used for different technology in different part of vehicles, not just EVs, but hybrid and even ICE vehicle. I like to use that as an example. Let's say I have a standard ICE vehicle with a traditional blower fan, and I have another vehicle with the same engine, same technology, but now the blower fan is now a DC, a three-phase DC motor, brushless motor, basically. And here in Canada, we do have some crazy cold winters, right? And we want to have some heat when we jump in our cars, and basically in the morning and drive to work. So with those type of blower fan with a brushless DC fan, three-phase motor, basically what I can do in the strategies, I can desynchronize each phase to generate some heat on the stator itself. And with the air basically in contact with those blower fan, we're gonna have like almost instant heat. So the more and more we're gonna see those type of application in different strategy related, even to comfort of the cabin, or even high voltage battery management. So that being said, we can teach with that product on different level, from the most basic thing to the more advanced stuff. But in all this condition, we can always use that ConsuKit, which is, I repeat, more as a project for the students to really build their own electric motor and learn everything that has to be related to those type of motors.
Jérôme, we have a question.
Yeah, that I was about to ask if there's any questions.
Yes. So somebody wants to know, how long do you expect it to take for the student to build the motor?
That is a good question. And you know what? Some instructors basically it's gonna, like I said, it's a project, so it's some instructor going to decide to let the student build in on different, let's say 2 days, 3 days. They can decide to teach during the construction. So let's talk about like, oh, now you're building the rotor, and I'm going to give you some theory about the rotor, and then you're going to jump to winding those bobbins, and let's talk about the stators, and let's talk about the polarity and stuff like that. So it can be built in the range of depending of the level of the students, but let's say I'm teaching high school students, pair them up 2 per unit. I can maybe have those students build it in the range of maybe 2 to 3 hours. But again, like I said, if I'm just let the students build the electric motor without theory, just following step by step, 2 to 3 hours can be a good answer to that. But if you add up some theory on each step, and trust me, there is, now it can be more a project for days. Any other question?
There isn't yet, but that doesn't mean we can't get some. Feel free to drop them in the Q&A, people. We definitely want to hear, even if you have feedback or questions. This is, like I said, a very different type of product than what we were usually launching, but we really felt it fills a gap in the industry. And I mean, I know we're all super excited about it. And if anybody needs quotes on anything about this, contact your concept sales rep. We are now quoting this and producing it. It's officially launched. Jérôme, you want to talk a little bit about the curriculum that I know is soon to be released?
Yep. So basically, like I said, each box have their own instruction manuals, how to build it. But the thing is, that product is also going to come with a presentation, a PowerPoint presentation, which you're going to have all the theory related to those type of electric motors for you and the instructor to be able to, like I said, talk about it, and can use those PowerPoint when the students are building the motor or right after. But it comes with a PowerPoint and also some student assignments where they're going to have to do some measurements, and of course the instructor going to have all the answer key for each individual student assignments. That being said, it's not because we are providing you some student assignments that you must use it to be able to enjoy the product, but is there for you guys, so you can use it if you want, or select the one that you found out matching your class.
We got a couple more questions. Somebody missed the very beginning and wanted to confirm that there's a resolver on that motor.
No, it does not have. So this is why, like I said, the rotor itself at first gonna have some hard time to spin. It's gonna try to move those magnets, but it's gonna try until the magnetic field is strong enough to basically make it spin.
What examples of components or vehicles that use a DC motor like this?
For example, we're gonna have, like, if we're talking about EVs, we can have like the high voltage AC compressor. We can have the electric motor for the drivetrain. If we're now talking about a standard vehicle, ICE vehicle, we can talk about a fuel pump. We can talk about some radiator fans, some blower fans, some can phaser. Basically, the more and more we're gonna see those type of 3-phase brushless DC motor.
And I was waiting for somebody to ask this, and Kurt, of course, it's the brilliant Kurt Ward asked this, and somebody else behind him also. They want to know about replacement parts and how often the components would have to be replaced.
That's basically, it's a really good question. So we do have inside. So imagine you're buying one unit. Inside that unit, you're gonna have everything you need to have to build the electric motor. Inside of it, you're gonna have some extra parts. So we do know that those bobbin, so if we can go back to the camera here, we do know that those bobbins, for example, are pretty small. And of course, without those bobbins, you won't be able to make the engine run. So you do have some extra bobbins here. But inside the box, you're going to have some extra parts for the bobbins. You're going to have some extra parts for the bobbin returner. You're going to have some extra parts for the stud itself, the stud that the bobbins are mounted on the stator. You're going to have extra parts for the nuts. That's going to keep the stud in place. So you do have some extra part. But imagine you build basically you buy a kit of 12 that came with a sort of a pelican case, as we can see here in the background. So let me just, here we go. So the kit of 12 came in a pelican box here. We do include some extra parts. So those extra parts are basically if we switch back here. So each unit came with 2 bags, bag number A and bag number B, everything that you need to have to build your own motor. So in a kit of 12, you're gonna have included both bag A and bag B for extra parts. That include the rotor, the magnets, the bobbins, the rubber band, the WIGO connector. But to be honest, you can still buy some wires, you can still buy some WIGO. This is off-the-shelf pieces. The bobbins, it's 3D printed here in-house, so we can include those. We can sell those if you need those. Let's say in the year after you need some extra parts, we can of course sell you guys spare parts. But the consumable, so the wires and the WIGO connector can be of course reused, or you can buy it off the shelf if there's something wrong with it. Let's say you're missing one or I don't know. So yeah. So as an instructor, if I really want to reuse the motor itself and everything on it, I can still use it. So I can still use each wire, just make the bobbins on one, then use the same wires. But like I said, those wires doesn't cost that much, so you can find it pretty easily over the internet and reuse everything else.
Will the controller run the motor forward and reverse?
No, only one way. So you can make it spin the other way if you're like changing every phase and how it's gonna be wound up, so clockwise, counterclockwise. But yeah, the controllers you cannot put it in reverse and then forward again and again. You need to change all the complete configuration of the motor.
Somebody is asking if you could go through some of the Oscilloscope settings for waveform.
So
for it.
So if I can go to the different Oscilloscope setting.
Yes.
I'm gonna use the other one. Here we go. Just gonna set everything up.
Should
So
you
of
put
course,
alligator clips over those needles?
yeah. So basically, what I did is I took off some of the isolation on the wires, so I can easily have my alligator clip from my U-scope on each individual phase. Same for the neutral here. And like I said, I can use the U-scope for teaching about basic U-scope usage by changing the basically the voltage per division. So, and again, the time frame, of course, per division. So I can use this setting here and basically teach about, okay, so here, let me be sure that I have a good. Sometimes those alligator. There we go. So yeah, so like I said, I can go ahead with the students and let them play with it and explore that if I'm gonna have a higher scale, so let's say 5 volt per division, and I spin my motor, I won't see any patterns because, yeah, of course, that generator doesn't generate a lot of voltage, so it's super safe. So I need to scale down my full per division. So now I can see that I have some patterns going on, and I can even make it slower, so about 0.1 volt, and basically sure that I have some good connection here. Here we go. And the faster I'm gonna go, frequency as at the top here, it's gonna also change. And the sine wave is going to change also. The amplitude is going to change. So when I say the amplitude is, of course, the amount of voltage that I'm generating as compared if I'm turning that motor super slowly. And as we can see, the pattern is not exactly perfect. As we can see, it's like there's little bump on the sine wave itself, but we can still see that the sine wave that we are generated is basically AC voltage. And this is, I don't know if I answered all the question about the functionality of the U-scope.
Yeah, I mean, I think you demonstrated it well. So,
Is there any question?
for schools with other programs and 3D printers, can they print out their own parts on that?
That I don't know, to be honest. It's
I would say try to be careful doing that because things are built precisely the way we had them, and unless you had the blueprints, it probably wouldn't be advisable. Would be
yeah,
my answer.
that's a good point. Yeah.
And then just to go over real quick, like you mentioned, we saw a classroom set of 12 and a classroom set of 24. In the in the 12, there's an extra bag, two extra bags of or extra bag of A parts, extra bag of B parts,
Yep.
one complete unit assembled as well. So you technically get it 13. And then in the classroom kit 24, just double everything. I mean, we kind of keep everything simple. So that,
And
I mean, that's how it works.
yeah, and basically when you say double everything out is like even the case was not going to be like a bigger case. It's going to be like 2 case of 12, because we still want to be easy to like move those units from different labs and or even buildings. So yeah.
And you notice we've used the term ConsuKit, so it's kind of a little marketing word we've come up with, but you're going to see ConsuKit used in future development products as well, because we understand like you have a classroom and you want to buy things in quote unquote bulk. So like we're going to create kits to help you fulfill your classroom needs.
Mm-hmm.
So, I mean, I think that's all the questions I've seen. I want to thank everybody for attending. I want to thank Jerome for his knowledge and time. Also, behind the scenes, I want to thank Megan, who is our marketing person, running camera 1 and camera 2 simultaneously. It's kind of a challenge. Al Santini always says, you live by technology, you die by technology.
That's right.
So technology was sort of on our side this time, so we were very grateful for that. I'm sure all of you as instructors feel that as well. So unless there's any more questions, I think we're good. And thank you very much, Jerome, and everybody.
Thank you, everyone. Have a good day.